Alright, so today we're going to still be using the trigonometry that we've been doing and our trig ratios of sine, cos and tan to be finding an unknown side in a right angled triangle. So in these first ones we're finding the value of the pronumeral, which is our letter, correct to 1 decimal place. Alright, so looking at this right angled triangle here, we've been asked to find this n value over here. We do have an angle involved, which means that we're going to be using our sine, cos or tan ratios. Alright, so looking at what we've been given, you always mark with the letter any number on a side. So this is a side of 200, it's opposite the right angle, so I'm going to write that it's the hypotenuse with a red H there. Now the one we're trying to find is over here, and compared to the angle they've given us, that's the adjacent side. So we're going to put an A in there for the adjacent side. So what trig ratio uses A and H? That's cos. So we straight away write the formula down. Cos theta equals A over H. Now we're going to sub in our numbers. Remember, it's always an angle going after sine, cos or tan. So we're putting cos 35 degrees equals n for A, n over 200. Now, once the substitution's been done, you get a mark right there, okay? You get 1 mark if you get that line right. Okay, now, we need to get rid of this over 200 part so that the n can be by itself. So we're going to take that to the other side and do the opposite, which is times 200. So then you just go to your calculator. Make sure when you're doing anything on the calculator with sine, cos or tan that you have up on that top of the screen there, you'll see D for degrees, right up the top there in the middle. There it is. Now, if that says G or R, all your answers are going to be wrong. Okay, you must make sure that that says D at the top of the screen. Now, if you don't have it there, if you press shift mode, right, now you'll see DEG written there with a number 3. So we're going to press number 3 for degrees. And that will make sure that up the top there you do have D for degrees. Okay, so if at any time it says R or G, that's how you change it. You cannot ask a teacher in a test, how do I change this? All right, make sure before you go into any exam that it already says D at the top of the screen. Okay, so when we go to our calculator, we press 200 times cos 35 equals, and it will give you the answer I've written on the board. We are going to write down the whole thing. Okay, so on your calculator, it's 200 times cos, which is up here, 35, and then press equals, and you'll get the answer that I've written on the board there. So we're going to 1 decimal place on this one. So draw your line after 1 decimal place. The next digit we circle, that's less than 5. So that means you're going to keep the number before the line as an 8. So that's your answer, 163.8, and we're in metres. All right, looking at the next question. So in this one here, we're going to label any side they've given us. So that one there, if we label it compared to the angle we have, that is the adjacent side. We've been asked to find R, and that is the side opposite that angle. So write those on with your red pen so you can't make any mistakes with this. All right, now I've written down the wrong thing here, haven't I? I said it was sine, it's not, so I've done the whole thing wrong and I have to start again. All right, so we're using opposite over adjacent, and that's tan. So I've done it wrong. We're going to fix it up as we go and see what happens. Okay, you can easily make mistakes on this. I was trying to do it in a bit of a rush, and that's how I've got it wrong. Okay, so we're using opposite and adjacent, that's tan. So write your formula down first. Opposite over adjacent. Now we're going to sub in our numbers. Always your angle goes here, so tan of 67 degrees, 36 minutes. Opposite is R, adjacent is 0.9. So now we're getting rid of our 0.9. So we're going to come to the other side, times by the 0.9. And now we're going to put that in your calculator. All right, right, so let's look at what it says and do exactly what it says. All right, so we're doing 0.9 times. Now it says tan. There's the tan key. Now we're pressing 67 degrees. Press the degrees button, and it's 36 minutes, 36. Press the degrees button again. All right, now we're going to press equals, and that's the answer we get. So we're going to write all of that down. All right, and now we're going to 1 decimal place, so we're going to draw our line after 1 decimal place. Circle our next digit. That's 5 or more, so this goes up by 1 to 2. Everything in front stays, and it's metres. 2.2 metres. All right, let's look at question 2. We're finding how far the stairs go up the wall. Okay, so here's your wall, here's your stairs going up. So we want to find that distance there, how far those stairs reach up the wall. Okay, so we're going to write down that that's x. Just write it on with the red pen. Now looking at it, we have this side here, which is our hypotenuse. And this side here that we're looking for is our opposite. So we're using O and H, which is sine. So we write our rule down, sine theta equals O over H. Our angle goes in after sine, so sine 40 degrees equals x over 355. Now you know what to do now. We're getting rid of this divided by 355. Come over here and times by it. Put in your calculator and you'll get that answer. And again, we're at 1 decimal place. So after 1 decimal place, draw your line. Circle the next digit after it. This is 5 or more, so this will go up by 1. Becomes a 2. Everything in front stays. And our answer is in centimetres. All right, let's look at the next question. So we're finding the value of x, correct to 1 decimal place. Let's label our sides that we have. This is the opposite side. This is the hypotenuse. So we're using sine. Sine theta equals O over H is your formula. Now let's sub in our numbers. Sine, the angle is 20 degrees. 35 over x goes over here. Now, when you get to here, if you have a letter on the bottom, write this on the side in red. So if you have a letter on the bottom in your fraction, you're going to do what I call the swap. Okay, now what does that mean? Let's have a look. So what you're going to do is you're going to get that letter and swap it with this. They're just going to swap spots. So if they swap positions, x will now be here. 35 hasn't moved. And on the bottom of the fraction is sine 20 degrees. So when you go to your calculator to do this, you're going to set up a fraction key, fraction button, and on the top we're putting 35, and then we're going to go down arrow, jump down to the bottom, and we're putting sine 20, and I always close that bracket off, then press equals, and you get the answer I've got on the board. All right, now, we're going to 1 decimal place again. So draw a line after 1 decimal place. That next digit is less than 5, so we're staying with a 3. Keep all of this, and it's in metres. Okay, let's look at question 4. Okay, now, number 4. We're finding each length correct to 1 decimal place again. So in this question, we've got a drawing here, and we're trying to find how far the person is from being directly under the birds. These are the birds. This is the person. The person is 187 centimetres tall. He is going to walk until he's directly under the birds. So that means he will walk from here to here, and when he's standing there, he'll be directly under the birds. So what we're looking for is this distance here, from where he is shorter than that probably, from where he's standing to being directly under the birds. That's what we're looking for. Now, to do this question, you need to find your right angle triangle. Let's get your red pen. Here it is. So draw it in there. Put your right angle in so you can see it. All right, now what information do we have there? Well, that's what we're looking for from here to here. If we slide it up, we can say that that is what we're looking for. So I'm going to write D up there. Now, we do know this side if we think about it. So to get that side there, we're going to do 2,450, all of that, minus the height of the man. So if we do that and take away the 187, we are going to end up with, let's see, 2,450 minus 187 equals 2,263. Okay. So that is the distance of that line. Okay, so now we're going to label the sides we know. So that side there is opposite our angle, so we have an opposite side. And this one that we're looking for is the adjacent side. So we are using tan. Tan theta equals O over A. Now I'm going to put the angle in. Tan 62 degrees equals 2,263, we just found it, over adjacent side, we've got D written down there. Now, you've got the letter on the bottom, so what do? We take that and this and swap spots. So, we now have the D is written over here, tan 62 is written down the bottom, and 2,263 is just going to stay there. Now, if you put that in your calculator, press your fraction key, and do it like we did before, you'll get that answer. So 1 decimal place, draw your line. This time we have 5 or more, so this is going to go up by 1 to become a 3. Leave everything in front of that. And the answer is in centimetres. Okay, next one. It says find the length of the support wire. All right, so what we have here is a roof of a building. All right, it's called gable roof gable roof, just looking at one triangular end of it. On the top we have a flag, all right? Now the flag pole is 2 metres high, all right? The one on top of Parliament House is a lot bigger than that. This one is 2 metres high. The distance from the top of the flagpole to the bottom of the roof is 7 metres. Now, this is an isosceles triangle. So when you've got a roof like this, any roofs are isosceles triangles, okay? Apart from, so they will have sometimes a skillion roof which dips down from one end to another, okay? So it sort of just goes straight down like this. But most roofs are isosceles triangles. You can tell that this one's going to be an isosceles triangle because those angles are the same. So if you've got 2 equal angles, then we have 2 equal sides opposite those angles. Right, so opposite this and opposite this, they will be equal sides. So mark all of that on with your red pen because that's not the stuff that they've given you. You need to know that. Now when you have an isosceles triangle, you can split it down the middle and it breaks everything into half. Okay, so it acts like a mirror. Right, so this is an axis of symmetry, so all of this reflects over and gives you all of that. All right, now how does that help here? Well, if we look at just one half of the diagram where we do have a right angle triangle to work with, let's just look at this half. You could have looked at the other half, but we'll look at that half. You can see it's a right angle triangle. So what do we know here? We do actually know this vertical side here. So what do we do to get that? Well, from here to here is 7, remember? And the other vertical is the flagpole, that's 2. So 7, take away 2 will give you this bit down here. So we know that that equals 5. All right, now if we label that side is opposite the 48 degrees. So we have an opposite side there. And we're finding the length of the support wire of this flagpole. Okay, so that's this bit here, the length of the wire. So we're going to call that X, and that would be your hypotenuse. So we've got an O and an H. That means we're dealing with sine. Sine theta equals O over H. All right, let's sub in. So we have sine 48 degrees for our angle equals. The opposite side is 5. The hypotenuse is X. That's what we're looking for. What do we do when we've got a letter on the bottom of the fraction? We swap. So let's swap spots. Now the X is over here, the sine 48 is down here, and the 5 stays there. If you go to your calculator and work that out, we're now going to 1 decimal place again. Draw your line, circle the next digit. That's less than 5, so this stays. And our answer is in metres. We'll come back in the second video and do some more examples.